Very exciting. Okay. So, the lesson today as I said this week in today's lesson is more focused on the geometric side of parabolas, all right, or of quadratics, geometric side of quadratics. So we're talking about parabolas, different properties of parabolas, and eventually using parabolas to solve application problems. I mentioned this to the other class. I don't believe there is a chapter in the textbook that has more application problems than this chapter does. There are so many applications of parabolas. I've contended for years, if there was a reason for it, I would have no problem coming up with enough stuff that only deals with quadratic equations to fill up an entire semester. It is a very rich, robust topic. We won't fill up a whole semester, but we will spend a lot of time here, okay? All right, some different terminology involving parabolas. The shape of the quadratic function is called a, I think I've used that word 3 times in my little opening monologue there. On the graph, A would represent what? Axis of symmetry or line of symmetry. Very good. Axis of symmetry. And this is very commonly referred to as AOS, axis of symmetry, AOS. It is the imaginary line that cuts the parabola in half. B on the graph is pointing to the vertex. Good. And what we are going to find when we start going over a lot of these application problems is that in most cases the vertex is the answer. Not always, but in most cases the vertex is going to be the answer to the problem. When the vertex is the graph's lowest point, we call it a, I think I heard it, minimum. And when the vertex is the graph's highest point, we call it a maximum. The solutions of a quadratic function are the, basically, x-intercepts. Of its graph. Wherever the graph hits the x-axis, that's where the solutions are. Okay? Solutions to a quadratic function are called zeros or roots. There's actually eventually a list of 5 different terms that we will learn all refer to the same thing. But for now, the solutions are referred to as zeros or roots. Today we are going to spend our time investigating and graphing quadratic equations written in 2 forms, standard form and vertex form. Now this idea of the fact that a quadratic can be written in different forms, this should not be like earth-shattering news. If you go back to linear equations, is that a linear equation?
Yes.
How do you know that? Besides the fact that I just said it.
Because x isn't being changed.
Yeah, there's nothing weird happening to x or y. X is not being squared, it's not being cubed, it's not absolute value bars under a radical sign. It's just x and just y. This is a linear equation written in what form? Standard form. This is not y-intercept. This is standard form, okay? But I could take this equation that is written in standard form, and I could rewrite it in y-intercept is the slope-intercept. Yeah, we call this slope-intercept form. Is it a different equation? Like, is this first line different than this new line? They're the exact same line. Okay, what's the y-intercept here? 4. How would I find the y-intercept up here? The y-intercept is the y value when x is what? 0. So if I sub 0 in here for x, this is gone. I'm left with 3y equals 12, y equals 4. It's the same y-intercept. And if you did the slope, it's the same slope. They are the same equation. They represent the same graph, but they're written different ways. I love the fact that in mathematics, we just call things what they are. We don't waste time coming up with flowery names for things. That last equation is called slope-intercept form because it gives you the slope and the y-intercept. Now, if the equation is written in this slope-intercept form, how do you find the slope? It's in front of x. Does that work with this first equation? Can you look at the number in front of x in this first equation and say, oh look, there's the slope? No, you can't, because it's written in a different form. That's exactly how these quadratic equations work. Depending on what form the equation's written in, you can get out different pieces of information. Right? There's three forms we're going to look at. Today we're going to look at two of them, standard form and vertex form. Guess why vertex form is called vertex form? Because it shows the vertex. The greatest sitcom ever written is Seinfeld. That's not an opinion, that's a fact. I just thought I'd share it with you all. The greatest sitcom ever written and ever will be written is Seinfeld. And one of the decisions that the producers of Seinfeld, Jerry Seinfeld and Larry David, one of the decisions they made early on in the show, before they even started, was they said, our episode titles are all going to start with the word the. Whether you realize it or not, whatever show you like, which is not as good as Seinfeld, all the episodes have titles. Actually, we're more aware of that today because we pull up a series on Netflix and it tells us the title of the episode when the episode starts. But all these episodes have titles, okay? And Seinfeld and Larry David said, when you get this group of writers together, and these are hyper-creative, incredibly funny people, we do not want them wasting a bunch of time coming up with really clever episode titles. We want them spending all their time writing really funny episodes. And that's the reason in every Seinfeld episode starts with the, so they didn't spend a lot of time thinking about it. The Soup Nazi, the pilot, the Chinese restaurant. Those are the names of the episodes, so they didn't sit around and go, what would be a really funny title for this episode? No, just get to the point. Same idea here. Why do we have these nice simple names in mathematics? Because we don't wasting time coming up with flowery names. Vertex form, why? It gives me a vertex. Standard form, you can find the x-coordinate for the vertex using that cool little formula, which you have to know. Opposite of b over 2a will always give you the x-coordinate for the vertex, and we'll talk for a second about why that's so important. That means x equals opposite of b over 2a is the equation for the axis of symmetry. That's the line that goes through the vertex. Now, I don't have the time in class to go through all this today. What is that? Negative b plus or minus radical b squared minus 4ac over 2a. What is that? It's on the wall. Very good. It is on the wall. Really nobody knows what that is? Because if nobody knows what that is, there's algebra teachers who are like very much crying right now.
I don't remember the name, but we learned a song about it in
Yes.
the Sewing class.
That's great. Do you know what you used it for? That's the quadratic formula, and it gives you the solutions to any quadratic equation. Okay? Yeah. If we don't know this, we're all going to have to know it here in a few weeks. Here's why I bring it up. We should all know opposite b plus or minus radical b squared minus 4ac over 2a. This part of it is b over 2, negative b over 2a. I don't have time to explain today why that works, but I can just tell you, if you know the quadratic formula, you've already memorized this. Negative b over 2a. Why is that important? Because I would like to make certain that I don't spend 2 hours on my math homework. I would like to get my math homework done as efficiently as possible. And since most of your homework tonight is graphing, the most efficient way to graph a parabola is to start with the vertex. If you're not starting with the vertex, you are gonna do at least twice as much work as the rest of us. You're gonna spend way more time than is necessary. Every time we graph a parabola, we want to start with the vertex. So I look at this equation. We'll walk through this one a little slower. What form is this in? Standard or vertex? Standard form. So in standard form, the x-coordinate for the vertex is the opposite of b over 2a. Okay, what's b for this problem? -2. Good. And what's a for this problem? 1/2. There's your a. There's your b. There's your c. Which was the opposite of -2, which is 2, over 2 times 1/2, which is 1. The x-coordinate for this vertex is 2. I'm not going to sub in all those points in that table. I'm going to start by subbing in 2. And if I sub 2 in there, that'd be 2 squared is 4, times 1/2 is 2, minus 4 is -2, minus 2 is -4. Which you can do on your calculator. Now I'm going to sub in 1. 1 squared is 1, times 1/2 is 1/2. Minus 2 would be -1 and 1/2. Minus 2 would be -3.5. And here's honestly where the magic happens. Parabolas are symmetrical, which means if I sub in 1 and get -3.5, I will also get -3.5 when I sub in. No. What's the x-coordinate for the vertex?
2.
So 2 is in the middle of this parabola. There you go. 2 is in the middle. 2 is the vertex. So 1 and 3, 1 unit in either direction, will give me the same results. That's how you get your homework done and not have it take 2 hours. I'm going to sub in half of these numbers. Would we rather sub in 4 or would we rather sub in 0?
0.
0, absolutely. And because parabolas are symmetrical, I don't have to sub them both in. This, ladies and gentlemen, is why you start with the vertex. It makes getting your table of values so much faster. And by the way, there is no workaround to the table of values. It's not like there's another option. You know, I'm not gonna say I feel totally bad, but maybe I feel like we mislead you guys a little bit when you're growing up in mathematics and we start teaching you about graphing. Specifically, we start teaching you about graphing straight lines. Because we have you do all these tables and and then one magical day you walk in and we say, slope-intercept form. No more tables. And I can just hear people in the back of their mind saying, why didn't he start with this? Why didn't we do this first? Why have we been doing all these tables for the last 3 months? There's reasons. A lot of the reasons have to do with quadratics and cubics and radical. There is no substitute for this. Most of you are getting so much better at your graphing, but I'm still grading the most recent tests that had graphing. The graphing calculator went in. But the test that had graphing most recently, and some of you are getting to like the parent function. You say, oh, parent function, quadratic, looks like that. No. The parent function for a quadratic equation has points at 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. That's the parent function. You can't just throw a parabola on there that opens up or down. you have to have the actual points. Same deal here. I need the actual points, like 2, -4, 1, -3.5, and 3, -3.5, and 4, -2, and 0, -2. As far as I'm concerned, 5 points is good enough. But I just, if you're waiting for the magic day when I'm gonna come in and come up with something like slope-intercept form, it's never gonna happen. What? Oh, okay, all right, yeah. Enjoy your fun. Okay? Yeah, that day's not coming. This is how we graph quadratic equations. Sum and x's get out y's plus 1's. It will never change. The nice thing is, have a good day, if the equation is given to us in vertex form, figuring out where to start is much easier. Question 2, that's in vertex form. Where's the vertex? -3, 4. Now, there are plenty of folks who figure that out because they love this equation, and so they talk about identifying h and identifying k, and I think that's great. I'm much simpler than that. We just got done doing all this stuff with translations and transformations. Okay, so look at this equation. How is the x being translated? It's x plus 3 in the parentheses with the x. How's it being translated? Left 3 plus 4 at the end. How's that being translated? I don't need the y equals a times x minus h minus squared plus k to figure that out. If you know the translation rules, which work for everything, then if it's written in this form, left 3, up 4. Now that doesn't work for the first one. Why not? It's in standard form. I don't just have one x value in a parentheses that's being added or subtracted. I got all kinds of stuff going on in there. It's a different format. Well, for vertex form, I need to know the translation rules. The translation rule says x plus 3 means left 3. Plus 4 at the end means up 4. And then I can still use all this beautiful symmetry. Would you rather sub in -4 or -2? I'd rather sub in -2. Because -2 plus 3 is?
1, negative, no 1.
1. Very good. 1 squared
1,
times -2
Negative
plus 4.
2.
Would you rather sub in -5 or -1?
Negative 1.
I would too. -1 plus 3
2.
squared
4,
times -2 plus 4.
4,
And there we are. 1, 2, 3, 4, -5, 1, 2, 3, -4, -4, 2, -3, 4, The point of the lesson today, the major point, this is the first part of section 2. Can you graph a quadratic equation? Tonight they come in 2 forms, standard, vertex. That's how you graph them. You always start with what? Vertex. Always start with the vertex. Are there any questions? I would like you, on the next page of your notes, to try number 5 and number 6. Please feel free to be discussing your results with your neighbors as you're working through it. Thank you. The last two. 5 and 6. Okay. Question 1. You have to identify what form this is. For number 5, what form is that?
Vertex.
Where's the vertex? 2, 5. X minus 2, so it's been shifted right to. The vertex starts where? Maybe I should have said that. The vertex starts at 0, 0. So this tells me the vertex has been shifted to right, 5 up. 2, 5. Okay? Now, you might be surprised. I don't know. I'm going to sub in either 3 or 1. I'm actually going to sub in 3. And the reason I'm going to sub in 3 is because if I sub in 1, 1 minus 2 is -1. I prefer not to deal with a negative and squaring a negative. Some silly things happen in those cases. I'm going to sub in 3. 3 minus 2 is 1 squared times 2 plus 5, which means this is 7. I'm going to sub in 4. 4 minus 2 is 2, squared is 4, times 2 is 8, plus 5 is 13. 0, 13, off the chart. 1, 1, 2, 3, 4, 5, 6, 7, which means that'll be 7, and this is 5. Make sure it looks like a parabola. Don't make it a V. What kind of graphs are V's? Absolute value. You got to make sure you make it a kind of a smooth curve. What form is this one?
Standard.
Standard form. I would like to start with the vertex. So I'm going to find it. Opposite of B, what's my B value? Over 2 times A, what's my A value? Which is -2 over +2, which is -1. There's the x quantified vertex. I sub that in. That would be 1 minus 2 is -1, minus 1 is -2. And if I sub in 0, I'll get -1, which means this is -1. And if I sub in 1, that'll be 1, and 2 is 3, minus 1 is 2, which means this is 2. 1, 2, -3, 2, -2, -1, -1, -2, -1, 2. There's my graph. Start with the vertex. You get that? Okay. Some last questions, which we haven't discussed. This is maybe kind of a preview of coming attractions, if you will. What's the domain for this function? This function. Question 6. What's the domain? Very good. Every quadratic that we're dealing with right now. Every quadratic solved for y, or no, that's not exactly right. For right now, this domain is all real numbers. This range is y is greater than or equal to -2. -2 is the smallest y value in the whole function. Everything else is larger than that. So the y, that's a vertex. Okay, all right. Good, that's all right. And then this next concept is the one that a lot of students takes a little while to get it. Okay. As I am moving, I'll hold up this folder so you can see it better. As I am moving from left to right, what are the y values doing? Increasing or decreasing? They are decreasing. Very good. They are going down until I get to -1. As you move from left to right, the y values are decreasing until you get to -1. Once you get past -1, what are the y values doing?
Increasing.
So they're increasing once you're past -1. When you're approaching -1, they're decreasing. You go past -1, they're increasing. Now, notice I didn't include -1, because I can't include them both. And if you want to be really hyper-technical, at -1, the function is neither increasing nor decreasing. At -1, it's at a point. All right. So you have your homework done for tomorrow.